Here are the questions on the problem set. Increase in length is in proportion to the change in temperature. So find delta T by delta L. And once you get that, you can calculate the temperature for a particular length and then substitute the given values. For the first, you get 44.2 degrees Celsius, and similarly for the second, you get 78.7 degrees Celsius. Now for one to fit another in, well, surely the diameters must be equal. And so that's the formula for change in length, from where we make the difference in temperature the subject and then get the temperature. T is T naught, which is the initial, plus that quantity. Therefore, it has to be cooled down to negative 69 degrees Celsius. Well, in number 3, it's about change in volume. The volume of a sphere is 4/3 pi r cubed. So that's the initial volume, and then you get 6 times 10 to the negative 2 centimeter cubed, which is going to be the change in volume. In 4, that is the new length of iron, and that one for brass, and they need to be equal to each other. I'm trying to make change in temperature the subject. You get the change as negative 163, and therefore the final temperature must be initial take away 163, which is negative 143 degrees Celsius. Now for the B part, switch the initial values of iron and brass and calculate in the same way, taking care that you don't get mixed up between the alphas and the original lengths, and you would get the final temperature is 180 degrees Celsius. So this time you got to heat it. To change Celsius to Kelvin, you got to add 273.15 to be precise. So that's the first one in Kelvin, and then the second one, it being such a big number, doesn't make any sense of adding such a tiny 273.15, so it's approximately the same thing. And so the percentage error in the first case, because 273.15, or rather 273 is the difference, divided by the original times 100, 6.4%. But in the second one, of course, it's going to be much smaller because the number here is much bigger. So you get 1.82 times 10 to the negative 3%. Now, to do these problems, we have to consider that the gases are ideal gases, and volume of 1 mole at STP, 1 mole of any gas at STP occupies 22.4 liters, which is 22.4 times 10 to the negative 3 meter cube. And you need to know that information. Mass of 1 mole of oxygen is its molecular weight, but we got to have it in kilograms, and since we are considering 1 mole, we know its mass and we know its volume. Just divide to get the density. In number 7, first find the number of moles of nitrogen and then use the ideal gas equation to find the volume. Remember that pressure always has to be in pascals. It cannot be in ATM. And temperature has to be in Kelvin, unless it's a difference when it could be in Celsius. Now in the B part, find the additional moles that come in, so that's the total number of moles now. And assuming that the volume is constant, find the new pressure. Eight. We've also got to assume that air is an ideal gas. And therefore we can use the ideal gas equation. We know that in this case pressure and volume are constants and R is always a constant. So the right hand side N times T is constant. Therefore N1T1 is equal to N2T2. Got to have the temperature in Kelvin all the time. So N2 by N1 is 0.926, and if we start with an initial number of moles of 1, then you see that the difference is 7.4%. 9. The volume of the ocean is the surface area of a sphere, which is 4 pi r squared, multiplied by the average depth of the ocean, delta y, and then multiplied by 0.75 to show that only 75% of the surface is covered by water. So that's the total volume of all the oceans. And find the mass. Mass is volume times density. It's the density of seawater. That's why it's 1025. And then the number of moles is always total mass divided by the molecular weight in kilograms. And it's H2O, so it's 2 plus 16, 18 grams, which is 18 times 10 to the negative 3 kilograms. We get 6.55 times 10 to the 22 moles. 10. Pressure, according to the kinetic theory, is 1 over 3 mn v bar squared. And density is m times n. Because n here is the number of molecules in 1 meter cube. And m is the mass of one molecule. So when you multiply them, you get the density in because it's the total mass in 1 meter cube. 11. (1300 moles is 36.4 kilogram density. is mass by volume. So 36.4 divided by 8.5. And the root mean square velocity is given by square root 3 times the pressure by density. Pressure is 2.1 atmospheres, and you got to change it into Pascal. That's why you multiply with this to change it into pascals. And finally you get 386.2 meter per second, which is not slow. 12. Make volume the subject in the ideal gas equation. 1 mole atmospheric pressure 0.0225 meter cube. And 1 mole has the Avogadro number, which is 6.022 times 10 to the 23. So the volume of one molecule would be the total volume divided by that number. And since volume is the cube of the length must be the cube root of the volume. And when you raise something to 1 over 3, it's just the same as taking the cube root. So, thank you.